Good morning, everyone. We're almost done with circles. We did angles, we did lengths, and now we're doing the arc length and arc area. Okay, so yesterday we did the arc length where we know it was a piece of the circumference. It wasn't the full circumference of a circle, it was just a section. And we use those sections by getting the central angles. Well, today we're going to do area. So we're going to do arc area. So it's exactly like arc length, okay, where we're going to get a piece of the circle. In this case, we're going to get a piece of the area of the circle. So the area that we know is pi r squared, right? And that covers the whole entire circle. Today, we're going to do the formula for arc area of a sector. So what that is it's a piece of the circle, and we're going to use the central angle and the radius to get us this area. Okay, so again, we are going to use, just like circumference yesterday, we used circumference formula and then theta over 360, theta being the angle and r being the radius, right? This part of the formula was the circumference. We're doing the same theta over 360, but now we're using the area formula instead. Okay, so whether we want area or arc length, you need to know, are we using the circumference formula or the area formula? Usually, if the regions weren't canceled, you would have to know this formula and memorize it. All right, but since we're at home, you really don't have to memorize it as of right now. So pi r squared is the area, and this piece is going to be the section of the full circle. So theta is your angle. So let's look at model problem 1. So this is model problem 1. I already worked it out. So the angle theta is 300 degrees, so that's going right here. And then the radius is 3, so that's going in. So again, our formula was theta over 360 pi r squared. So all you got to do is plug in theta and plug in r, just like we did yesterday using the formula. All right, what you could do today, so I don't really, unless it says in terms of pi, you can plug everything except pi in and get it in terms of pi. You would get 7.5 pi. But today, I just want you to throw everything in the calculator just the way you see it and get me a decimal to the nearest tenth. Okay, and centimeters or feet, it's going to be centimeters squared if you notice. Okay, so when you have area, it's always squared. In this case, in number 2, when you see a question that's in radian mode, well, for radian mode, you must first change it to degree mode first. Baby, shh. Change to degree mode first, and then you can plug it into the formula. Okay, so a lot of people had questions with this one yesterday with the circumference. If it's given in radians, change it to degrees first from Monday's lesson, and then plug it in and solve. Again, you're plugging everything in and getting me a decimal. For model problem 2, it's a little different because instead of giving you the radius and the angle, it gives you the area already. So the area goes in for A, and then the radius goes in for r, right? And then we're looking for theta. So if we're looking for theta, you have to, well, if there's a pi on both sides, those cancel. And then we got 6 squared is 36, 36 over 360, and then you just cross multiply. If I cross multiply, I would get 4,320. And then divide by 36, and you'll eventually get your angle. And again, you could always do a check when you have this type of question by plugging in the angle into the formula and seeing if you get the area back. Okay, in this case, the area is in terms of pi, so don't put pi in the calculator. All right, so try the examples. I will be helping you if you post questions, and I will send you an answer key tomorrow.